This conference will now be recorded.
Hello. So I think we have almost everyone in. So let's get started. So I hope you all can see my screen. So can you hear me properly? Hello? Hello? Okay, fine.
Yeah, yes, we can hear you.
Okay, right. Thank you. So the last class. Okay, let me take one more recording. The last class we were discussing about HDFS high availability. So high availability is nothing but we are adding one more. Okay, so 1 second. Okay, so what we did here is like we added one more name node so that one will be in active state and one will be in the standby state. So we have got journal nodes. So that will take care of this shared edit file. And we have got the zookeeper failover controller that will do automated failover. So whenever the active gun goes down, the standby will become automatically active. So with the help of failover controller, so which is part of zookeeper service. Again, if zookeeper is down, then I just explained the way to recover that. So we have option to do manual switchover, but for that the automated failover option has to be disabled and then use a Hadoop HAdmin then failover commands to do that. Okay. And so basically the standby name node will have up-to-date metadata information, and this is with the help of journal node. And also the failover controller make sure at least one is active at all the time, and whenever the active goes down, the standby will take that role with the help of zookeeper failover controller. So here, so not manual effort is involved, so we can do everything with the help of this failover controller. So like if I just turn off this active one, the standby will switch to active state. Again, if I just turn off that, then this will again become active like that. It will behave. So the manual option require so certain configuration changes. So that is something like automatic. I think uh, we can just search with the okay, yeah, enable automatic failover. So this option has to be disabled, then only that command line option will work. So dfs.ha.automatic failover enable. You can just search with automatic or just search with the failover uh, thing. And I think the failover we have a lot of options. So better try with the automatic. Okay. So automatic enable automatic failover. So this has to be disabled and then restart. Then only we should be able to do a manual. Uh, I mean, so we should be able to do it in a manual way. Okay. So that's about HDFS high availability. And if you look here, so here some process. Okay, so if you see here, HDFS, some error is there. Okay, so checkpoint status. So this is because the checkpoint has not properly done. So, so in that case, what I have to do is just switch to my ID. Sorry, I think from root, if I do this won't work. So I have the key tab file of HDFS. So basically, I need to have the super user privilege. I'll just show you how to override this error. I think we already explained this one. So just to do a klist-kt and find out the key tab option. Then do kinit-kt, whatever the key tab, and then this principal name. So after that, if you type klist, we got HDFS user key tab. So we use HDFS, just enter HDFS DFS admin. So this is the option we need to use. So most of the admin command line options are available with this one. So HDFS DFS admin. So actually we need to use the save namespace option, but this won't work because our HDFS is not in safe mode. So what we need to use here is, so DFS admin safe mode. Sorry, I need to use safe mode, enter, then save, sorry, not the safe mode, save namespace. Okay, then what I have to do is, so I need to leave this safe mode. So that means, so during the safe mode, only read operation is supported, the write operation won't support. I'm just leaving from this safe mode, and I can just use this get option so that it will list the safe mode status. Okay, so safe mode is off. So now if you go back here, then after some time, so this error will go away. So, and we have some other error, some critical error here. So you can see this is all showing as green except this one. So process status. So looks like some processes are down. Okay, just hit here and go to the instances. You can see job history server is showing us down. So let me do a restart on that. Okay, so let me just see this chat option. Okay, so what cases the failover will work automatically? I think this is I explained very well in the last class. So whenever the zookeeper service goes down, then only the problem will have. Okay. Uh, so why we need the manual failover is, so due to some reason, see why we need the failover, then we need to think who is doing this automatic failover. So failover controller. So this failover controller is part of zookeeper. Then if zookeeper goes down, then only we have to do this manual thing. I think so we explained that in last week very well. So this is part of zookeeper, and which is responsible for automatic failover. I mean automatically it will convert active and standby. See, if that service goes down, definitely we'll have to do it manually. And also I explained well, like so using I just turned off this zookeeper services and then did a manual failover. Okay, so that's about HDFS failover.
Sujesh, a quick question.
Yeah.
So if the ZKFC, the failover, the service you just talked about, if that is running on that is running on master server. What if the whole node goes down, which contains the service? Then what happens in that case?
This one, failover controller you're talking?
Yeah.
Yeah, in that case, the failover controller always should be available on that particular host, which is either active or standby. Okay, so in
Right.
that case, what we have to do is just to turn off automatic failover controller and make this as master one. Then later we can add that services, whatever the corrupted one or not available one.
I see. And at one point of time, the controller will be running on both the nodes, master 1 and master 2.
Yes, this will be running on the host where your name node service is running. So one will
Yeah.
run on the active name node and one will run on the standby name node. But journal node we have option to do it on any host.
Right.
Okay. Okay.
Yeah.
So if that goes down, definitely, so we'll have to do some manual effort. There are a lot of combinations of events may occur.
Yeah.
So sometimes if this is not okay, say for example, if our master 2 machine goes down, so sometimes if this is not in active state, then we may need to manually make it active state, and so that the service won't be get interrupted. And after that, we can just slowly add the remaining services or recover that and do it as usual. So our main intention is to keep the availability so that the user won't get affected.
Right. Okay. Thank you. And I hope that probably we are going to cover the backup recovery kind of scenario in other sessions, isn't it?
Yeah, that is an option like so BDA, yeah,
Okay.
snapshot. Yeah,
Hey, Sujesh, this Prasad here.
yeah.
What are the reasons for zookeeper failures like in real time scenarios?
The zookeeper failure means okay. So the zookeeper node itself goes down. Okay, so a lot of issues. So it can be any reason. Like say this any like I said. So zookeeper work in a cluster way. So in this list, if two of the zookeeper services goes down, then the entire zookeeper service will be unavailable. Okay. Say for example, if master one and master three are in the one rack, and maybe something happened, some power supply or something went wrong with this two servers, and that is not available, then zookeeper may not be available. Maybe the disk corruption. There are like any other cases, like any one server is can be or service can be unavailable due to a number of reasons. Similar thing may happen here also. Like in your Oracle case, like if we have a real application cluster and two is there, right? One can be go down,
Yeah.
maybe due to a different reason. The same thing happen here also.
Okay.
Maybe the disk pull issue, then OS related issue, or something network issue. A lot of things can cause this one.
Okay. 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 Sorry. Okay. The zookeeper. Okay. The regular normal causes. Okay. Okay. Got it. This will be
Okay,
maintained.
so
Any logs like zookeeper logs will be maintained separately to identify the reason.
every service will have its own log. So you can just go to /var log directory, and what you have to do is, so I'll just come to that point in detail. So var log message directory will have the complete logs. Okay.
Okay. Okay. Okay.
So next is yarn. Okay. So if you look into the yarn, you can see a resource manager and node manager. Actually, the yarn, the core component is resource manager. Okay. So okay, and node manager work on this is actually the on workers, and this is on master one. So we have the multiple node manager, but only most cases we have the single resource manager. Resource manager is a master component. So whenever we submit the job, so that will reach us to the resource manager. So resource manager will have the different options like scheduling and job management. So it's a core part and the master thing. So if anything happened to the resource manager, entire yarn framework will be down. So that the no jobs will be running. So the node manager is something like it's a worker component which will be running on the worker. Actual job will be running on this job manager, node manager. So for example, if one of the node manager goes down, still it won't affect because the job will be distributed to the other node managers. Okay, but if resource manager goes down, the entire yarn framework will go down. So let's try to let me do a k destroy and just to do a k in it. Then I'm just running a simple MapReduce job. Number of mappers, let's say 100 mapper and sample per mapper 10. Just run this job. So when I submit this job, it will request this to, actually the request goes to the resource manager. So the resource manager, we have got only one resource manager, and resource manager will accept that, and then there is a set of a sequence of operation that resource manager do in order to run this job. And while actual run will happen only on this worker host, like node manager. So number of node manager, if again while running, if some of the node manager goes down, still it won't affect the job. So there is a mechanism in backend that will take care of that, and that will rerun that failed part. But the resource manager is important, which is a master component. So while the job is running, so let me stop this resource manager and see what will happen. Okay, I just stop the resource manager. So this job won't progress, but we won't get the progress. And also, let me let me run another job also. See, this is failing and not able to connect. So let me start it. So what I mean to say is, like, if resource manager goes down, so it cannot accept any further job. Okay, and whatever the running job, maybe it's process run in the node, but we won't get the status, and also when it's completed, so it won't get updated that files, and we won't get the result. So this resource manager also single point of failure. However, we have option to add multiple resource manager. Okay, so let's just refresh. So this job has failed because okay, so if you see this event, you can see it's not able to get the option. Let's try it again. Now it started running. You can see here, this is also running because now our resource manager has started. So both jobs are running now. So we have, like I said, so we have option to add extra resource manager. So we need not to do nothing much like a name node configuration. So it's very easy and straightforward. So what you have to do is go to the yarn, just hit there, and from the action, so we have option like enable high availability. Then it's asking an option to add new host where you want to add your resource manager. So let me add it on master 2. Just hit OK. So this is one is our currently existing resource manager. This is the additional resource manager. Go ahead and hit continue. So this will add one more resource manager. Okay, enabling resource manager availability is very easy and straightforward. So we can just enable it from the yarn window, and so this wizard may take some time. So it's just refreshing its configuration and adding one more resource manager.
Sajesh,
Yeah.
for every interview, so many questions they ask like, what are the reasons for failure of resource manager? What are the failure of general load failures? Like for everything, the common reason we can say like is a network issue or a disk corruption. These are the issues. These are the issues, or any other issues like.
See, what are, yeah, these are, you can say these are the issues you faced. Okay.
But
See,
they are
the
asking for the
interview,
reasons.
yes, yes. The reason is that is something like they are just trying to find out whether you really worked or not. So, so they will easily, okay, so they are not expecting all the reasons behind this. So if you are, whether they are just checking whether you can confidently tell, okay, one of the incident you really seen. So for that, only one option is you do the practice in multiple ways. Then only you will come to know the issues you really faced. So that is something like they're just evaluating whether this person really worked or not.
Yeah, but what are the things we come across like? That's what I'm asking like, so that those areas we will go directly and practice those areas like. We cannot corrupt the
That,
disk, right? When we work on a
no, no,
particular.
you can corrupt. This is nothing but in AWS instance only, right? See, you can deploy, redeploy new cluster. That is what I'm saying. No, no worry. But in actual scenario, you may not get even these issues. So here you can simulate all the issues. See, okay, I just turned off this zookeeper and see, okay, so this is down and this one I was able to do. So you can do everything. Only thing is the worst case, you may need to redeploy the cluster again. That also you can do. So then only you will learn. So otherwise, like even if you just in interview, especially if you just read, okay, the reason and all, if you tell, they can also really easily understand. Okay, so this person is read from somewhere and doing. So better try to get that information and to do simulate in your own environment and see what are the options you used. Okay, how you recovered, all those things. So rather than doing all those things, okay, you can say one issue like, so my file system was full, and the file system full also you can simulate in your environment. Only thing is you need to know a little bit Linux. So there are commands to generate huge size files. So maybe your server won't respond after that. Maybe sometimes the worst case you may not be able to restore it back. However, try that options. So in that question, they are not expecting all the reasons that is causing the zookeeper. So they may ask, so some of the cases you have come across or you have seen in your environment. So sometimes you can say, okay, I haven't seen this issue. That's it. So if you go to the instance here, then you can see two resource manager. One is in active and one is in standby state. And okay, so maybe this is the reason is when we enable this one in between, yeah, our jobs went. So I'm just submitting one job, just a 30 mapper, and so job has started, and so this is running, and so while it's running, let me try to stop this resource manager. Just hit that and then stop. Okay, close. So the active is goes down. Still we have a standby. Now, if you just go back here, just wait few seconds, you can see the job is continuing with the other one, other host. Okay, so you can see the progress here. Then if you just refresh this page, maybe it takes some time to update this page. Yeah, now the standby has changed to active state. So here also in backend, the portion of Zookeeper service is doing this task, but it's not visible to us. So for us, we have the option, like even if one of the resource manager goes down, the other one will automatically come to active state. So let me start it, and this will change to standby mode.
So looks like it's at the back end, it creates a kind of a pool, isn't it? A resource pool sort of thing, where when you submit a job, this is where it gets allocated, isn't it? And then you switch it, and it will switch the active and passive sort of thing.
Not like that. You can just see here. A job submission, if you just download the client configuration and just open this one. Just a second. We have option to download the client configuration. Go to that folder and so yeah, on site. Just open this file. See automatic failover, and so this is also just checking with the zookeepers. Okay,
Yeah.
so zookeeper will control the connectivity and all those things.
Yeah, true, actually. Right.
Yeah, and that will helps to connect one of the active one. So basically, all those thing is controlled by zookeeper. Maybe the yarn is connecting via zookeeper only, and zookeeper will have the particular directory for this one, and so we have got two 58 RM58 and RM59. So this has got, you can see like two resource manager has written, and somewhere you can see the RM1 and RM2 information. Where is that? Tracker. Wait, codes. RM58 and RM95. So on which port and which host this RM58 is running, and on which port and which host this RM95 is running. So the zookeeper will do that in backend.
Right.
Okay, so this is about the resource manager HA. So similarly for Hive also we have option to enable high availability.
One
So
quick
high,
one. Sorry,
yeah,
Sajesh.
no problem. Yeah.
Sorry. There was a job history server. What is the significance of that component?
Okay, so job history server will keep the history of the job. Okay, so we will see that shortly. So
Sure.
post
Thank
to
you.
this AI availability, so we will see more on the yarn, like what is in backend behind the scene, how yarn works. So how to troubleshoot a job, all those things we can see. So basically, we will have that job history. Like if you go to the yarn and resource manager web UI. So now we have got the two, master one and master two. And so here you can see the details about the job. So this is controlled by a daemon. So that is called job history server. And so that will take care of all this backend logging, all those things. Okay.
Okay.
So before
Yeah.
moving, can you please explain Okay. Now, so if you move to Hive, so go to the instances. So we have seen the Hive, like how to create the database, tables, and do queries and all. And here also, the problem is if this Hive server 2 and Hive Metastore server. So these are the two main components. If any of these components goes down, so our Hive server will not be, Hive service will not be available. One of the main services Hive server 2. Okay, so which here also it support high availability. That means we can have multiple Hive server 2. So I'll show you how we connect Hive. So we just use beeline. So -u jdbc Hive 2 : Hive server 2 server. So this is the master one, and the port where Hive server is running, and the default is the default database. Since it's Kerberos enabled, the Kerberos principal name for this Hive, and this is the way we connect for Hive using beeline. So it's connected. If you just use raw databases, it
Sajesh,
will list
Sajesh, one
all
question.
the. Yeah.
When the user submit a Hive command, Hive
Mm,
connection or Hive command like a just select star from database or some show database,
mm.
and what are the activities run in the backend? Like what is the role is playing by Hive server 2? What is the role playing by Thrift server? Can you explain in detail? See, we know how
Yeah.
to connect and how to run the jobs, but what
Mm.
exactly is background is running? Like, what is the importance of Hive server 2? For example, if the user is connecting, who is verifying the authentication, and what is the relation between Hive server 2 and Thrift server?
Okay, so the thrift server is just for connecting from external programs like Pig or Spark. They can make use of this service for connecting. Okay, so mainly Hive server 2 and Hive Metastore server are the core component. So Hive server, we can say it's the main component, so which will accept the job, and it will connect with the Hive Metastore server. So Metastore server itself, its main role is to manage the Metastore. So there will be a database involved in backend. So it will work with that database, and all this is managed by Hive Metastore server. So Hive server 2 only will take care of this all this authentication part, then accepting the job, and in backend it will distribute that as to map reduce job. So like I said, like not all the Hive queries will run as a MapReduce job. Only the aggregate functions will be converted into MapReduce job. So that is why what Hive server is doing. So Hive Metastore server will manage this Hive Metastore service. So you can see like we have one relational database, so which is taking care of this Metastore service, and Metastore server manage that connectivity and all those things is managed by. So mainly even if you just turn off this web catalog server, so our connectivity and query will work. Okay, we will see that.
You mean Hive Metastore will keep all the user credentials for the Hive users?
No. That details it will just doing. I mean, mainly for the connectivity with the Metastore database.
But user authentications will be done by Hive Server 2 or Hive Metastore server?
I server 2 only.
Okay. Okay. Internally, is there any processes executing in the Hive Server 2? Inside the Hive Server 2, any other components are there?
No. Hive server 2 itself running as a JVM daemon. Okay. So I just turn off web catalog server. So just for us to connect this database, doing the query or creating the tables, database and all, this thrift server is not needed.
Oh,
So it's
webcat
used
server
for
is nothing
connect.
but a thrift server, huh?
Yes.
Oh,
It just provides some. It gives some API option for other program to connect. Okay, but the web server, Hive server 2 is a core component, so that is taking care of Hive. And whenever we connect or whenever we execute the job, then Hive server will take care of that. So and also while connecting this, so we are directly connecting to the Hive server 2, and the Metastore server it will just support the Hive server 2. Okay, so let's just add one
like
more.
any architecture related information more on Hive Server 2, like how it is going to take the user.
I think you can just go through this definitive guide. I don't remember which chapter is having that.
So,
So there is one chapter.
I would suggest, can I say something? I think I can see where Prashad's coming, because I have attended few interviews. I've been Oracle DBA for 18, 19 years. So I'm trying to do the same what I think Prashad is trying to do. Possibly, I could be wrong.
Okay.
There is the Hadoop definitive guide from Tom White is very good. So there are two aspects for interview. Yeah, people will ask you, theory questions, and they will ask you some real-time questions. So as Sijesh, as you rightly said, Sijesh, that it's a good idea. You do these practice at your own and come up. Prep your scenarios. Basically, I would suggest prep your scenarios and tell the same scenarios to them. That's it. And if they ask you like more detailed question, and you get this knowledge from textbook, that Hadoop, the definitive guide from Tom White.
Yeah, and again, one more thing I have seen is like if the interview is conducting by Indians, they will definitely ask a lot of nonsense theory questions. But if it's
Absolutely.
US or UK people, they will completely ask this scenario-based or real-time based.
Absolutely. UK people they didn't ask hardly anything, and second round people did from Tamil from Chennai, and they started asking me a small thing, literally. And this is where I think they try to catch you, basically. That's what they do.
Without knowing the architecture in detail, how you are going to answer all the questions, how you are going to understand the textbook. I mean, I don't know who is talking to, like, and I have faced so many interviews, I failed so many interviews, I passed so many interviews, but some people are asking in detail. Hive Server 2, I need in detail. In detail means if you go through all the Google documents, we need hours, months, years together. We need to read.
No.
That's
I
what
think
I'm asking the
I
crispy
think you are mistaken, fella. You're mistaken. Seriously, I'm telling you. Look, Cloudera themselves, they have got whole documentation. Yeah, and you look you look all the websites and probably look at the multiple blogs. You go to Cloudra, people who working in Cloudra, they run their own blogs. If you talk to them, I attend a lot of meetings. And they themselves suggest if you want to learn an architecture, there are two books, which is like one of them, which Sajis rightly suggested, a Hadoop Definitive Guide, Tom White. Yeah, that is the best one. You read it, you'll find it absolutely interesting.
Sure, I'll go to this. I never gone to the books.
Which is second one?
I have got all the PDFs. There you go. You have got in front of you. I have got a PDF. I can send it, but you can see it here. And there are multiple. It's a very, very big book. Google is not the solution. Google always gives you, tips. That is not a solution. No.
Yeah. I think because I also have gone through this a long back.
And which is the second book you suggested? Who was
Prashant here? Which what you talking about?
Yeah, which was the second book you were suggesting?
I'll send you two of them. I have got the PDF with me. I will upload it in this group.
Thank you.
So this is the reference book we normally use, especially for But this will take the first attempt you won't understand. Maybe you may need to read it multiple times to understand. Yeah, let's. I'll also just to go through the theory a little bit more, and I will explain to you. So basically, we just understand. So we have Hive server and Metastore. So web catalog and gateway is just a client. Okay, so let me go back here and see. So we just need to enable high availability for Hive server 2. So what we have to do is just go to the Hive action. Then there is an option like add role instances. And just from the Hive server 2, choose one more. You can choose from one more instance, Hive server 2 instance, which can be on master 1 or master 2, or we can have multiple 2 or 3. Sometimes some environment you can see 4 or 5 Hive server 2 instance installed. Okay, so we can have it to 2 or 3 or even 3 also fine. So I'm just adding only one more and then continue. So the Hive server 2. So we just added that, just select that and then go ahead and start. So while connecting to Hadoop, so we normally use this one, beeline -u, then this string and so sometimes if you have multiple Hive server 2 available, so most of the cases the people have the load balancer available. Okay, so in that load balancer, so say for example, you will just get one name. Okay, so how the load balancer will work is, so you will connect to, as an individual, you will connect to this load balancer will have its own IP. So LB dot whatever it may be, and it's having its own port. Say for example, 10,000 is the port. Then it will route its request to whatever, maybe Hive server to 1 or Hive server to 2 and just to 3. So say for example, consider we have got 3 Hive server 2, then we can connect it through load balancer. Okay, so there will be load balancer available. Load balancer will distribute this request in a evenly fashion. Like, so the first request will connect with this instance, second instance, because here we have got only 2 instances, so Okay, so forget about the third one. So we have Hive server to 1, 2, and whenever he connect, so the maybe the first request, some other people connect, then it connect to this one like that, so that both Hive server will be equally loaded. So you can have the multiple Hive server to instance in your environment, and you can configure. So this is nothing but a load balancer. So load balancer can be a hardware or an an application based load balancer. So we can have the physical or HA proxy kind of. HA proxy is just a load balancer. So HA proxy or the physical load balancer. So basically the network team will take care of that, and they will do the configuration, and they will give some IP address and port for this load balancer. And in backend it's like we use the Google DNS, right? So like from here, if I type Google, the DNS will route that request and connect to one of the web server. Maybe some other person connect, so route this request to some other IP. So
So it's not kind of one entry point is not given by Cloudera. So we need to create this multiple like one entry point, like sort of some sort of gateway for Hive ourselves using hardware load balancer. Is that right?
yes, it's all some environment I could see they have their own network team set up this load balancer, and what information we have to give is this. So they will give this load balancer IP or hostname and
Yeah.
the port, and in backend what are the IP address it's routing and port information, that also we will have to pass them. So then while connecting Hive server to, so we will use beeline-u, then JDBC colon Hive server colon, then IP of load balancer. So we use the load balancer IP and port, then default. But this IP is changed to any one of the working Hive server too. So
that will
like
load balancer will decide which way to go, basically, isn't it?
yes, a load balancer will have its own algorithm to
Yeah.
connect. Basically, it will try to distribute in an even fashion. So
Yeah.
otherwise, like if you are just hard coded connection, there is a heavy probability, like so most of the people are connecting the first one, so it will get overloaded. So here that won't happen because the load balancer will distribute the load in an evenly fashion. Like so, if first connection to this one, then second connection to this one, third connection, like that it will do. Okay, so now so I have a master one and master two. So let's try to connect here. So let's do with the master two. So show. So it's saying okay. So the problem looks like the principal name. I think I need to use here master 2. So this time I connected with the master 2. So I have option to connect with the master 1 also. Okay. Oops. So technically, if any one of these Hive server goes down, the second one will take care of that. So here I use this beeline option, and I was just using the hard coded value for Hive server 2. So master 1 or master 2, and based on that it's connecting. But there is one more option, like with the zookeeper. So we have option to connect it with the help of zookeeper. So let's just check that. So this is enable. So again, I don't remember that. Connect Hive server line. Okay. So this way also we can connect. So, but I don't remember the exact options I used. Okay. So in that case, so instead of load balancer, here zookeeper will work do the work, and whenever the connection comes, so it will distribute in a round robin fashion. So just to check with that, this discovery more dynamic discovery. I cannot see that option here, so I'll have to check. So JDBC, then what is the zookeeper? So you have to choose the zookeeper and use this option, service discovery mode equal to zookeeper, and zookeeper namespace, and then we'll have to use the principal name and connect. So I need to check that option, but I haven't tried that here. So maybe the next week I'll show you that. Okay. So what I mean to say is, like, we have multiple options, like use a load balancer, or we can use zookeeper for this dynamic discovery mode. So in that case, what we will use, so instead of specifying that Hive server to IP, so we use the zookeeper IP address, and then with the help of zookeeper, we will connect to Hive service. Okay. So if I remember, I tried it very long back. So let me just try beeline -u jdbc colon I2. So I need to use this IPN part of this zookeeper. So go to the Cloudera manager, then go to the zookeeper, then instances, and we have master 1, master 2, master 3, and the port where zookeeper is running. So you can easily find out from the configuration. Just search port. So 2181 is the port, and use 2181 comma 2181. So the second is second zookeeper comma, so master 3 2181. Then what we need here is service discovery mode equal to zookeeper, and the zookeeper name service Hive server 2. Principal
Sirish,
equal.
where can we see zookeeper namespace information?
I think here go to the Hive. I think a Hive will have that configuration. It's not available here. Configuration. No, I am not able to. So maybe I'll have to check that because I tried this service discovery mode long back. I don't remember exactly. And
But real time,
then
the names are not exactly the matching with this, right?
name, sorry.
We need to check from the cluster only. In real time, if you work in a real time environment, the same names will not be like namespace names and all will be differs compared to this Google command. That's what I'm asking. Where we need to find out.
Yeah, yes. This option, I remember some time back I tried, but I don't remember this exactly. But another thing is like most of the people are using unexpected fail from. I think it's not connected. Okay, so if it's a thrift connection, I'll have to just okay. So I'll just check this. Maybe the next week we will see. Okay, so how to
After
connect.
Hive server, after Hive server to it is colon. You have put comma. You keep a namespace equal to Hive server to.
Keeper name equal to I server to. Still, I think something somewhere I missed. I'll check that and we'll discuss that maybe next week. Okay. So, but so we have just to understand we have two options. So one is using a load balancer. So we can have multiple Hive server. So maybe 3 or 4. If you have 4, 5, I have seen like environment with 4, 5 Hive server also. So there we have a separate load balancer because if you use a zookeeper, I haven't seen like much people use it in production environment. So most of the cases they were using like load balancer, separate dedicated load balancer for this Hive server too. But with the zookeeper, we have just to do that with the dynamic discovery using zookeeper. So in that case, so zookeeper will take care of this distribution. So it will distribute it to first request to this one next to this like that. So the next important component here is Hive Metastore server. So which is again single point failure. So if this goes down, it loses its connectivity with the metadata service. So we have option to add multiple Metastore server also. That is also very easy. Just add a role instance. And here, so we have option to add one more Metastore instance. Just hit that and then continue. And the port, choose the default one, Metastore, on which port you want to run. Then go ahead and hit finish. Okay. So once that is done, so you may have to redeploy. So if you see something like this, definitely you need to hit there. Then it will update the configuration file. Just hit that, then restart stale service. Redeploy, then restart now. So mainly Hive server to, yeah, please.
Sorry. Oh, this is fine, absolutely fine. While it's running, I just want to ask, when you were connecting with Hive, not with the Zookeeper, before that, I could notice that when you were connecting with a principal name, which is Hive. So what I was thinking, take example, remember when we were trying to create a directory or create the example jars, you were using your own ID as a principal. So why? There are two questions. First, why we are using the Hive principal? Can't we use our own?
No, our own will not work. Say for example, this is here it's expecting. Okay, so like I said, there are multiple ways to connect. So one is with this thrift server option, like HTTP mode, we can connect, and we can connect by using this dynamic discovery mode. So by using direct Hive server too. So if I just use, I think it won't. So it's not connecting, right? So it's expecting here is sorry. So here it's expecting the principal for that Hive service. So sorry. Oops. So this is the Hive servers principle. I mean Hive service principle that we can get from the security, then Kerberos credential, then just search Hive. You can see. So we have got two. One is master one and for master two. So we have two principles for Hive, master one and master two. Earlier we have got only one. The second one is added. Okay, so this is in stop state. Let's start this one. Okay, so okay, so here you can see some error. Okay, so it's a failing to start. Okay, and so when you see go through this error message, so you can read that and try to troubleshoot. Okay. Say for example, what we did is we just added Hive Metastore service on master 2 and the service itself is failing. So concept, login concept, and so it's saying JDBC driver is not found. So something wrong with the class path or driver itself is not there. Okay. See, like, so you can say, okay, so Prasad and other people are saying initially. So if we appear for an interview, so they will ask different types of questions. So definitely some questions from the theory and concept, and most of the questions from scenario based. And especially they will ask what were the issues or challenges you faced and what are the actions you have performed to recover that. See, this is the one case. Like, okay, so you can say, so okay, so when they ask about the enabling high availability, they will ask, okay, what is the issues you faced? So you should remember all those things. Like here, the problem is something. So this is not starting, but when you check that error message, it's saying something. The driver is not found in the class path. So looks like something wrong with the driver. So we will log into that master2 and see how we can add that driver. So first get that IP address for this master2 and use that, and then we will log in here. So okay, then open. So maybe that's MySQL driver jar maybe missing. Y install MySQL hyphen.
Sujesh, why I'm asking all these questions, because the real time issues, if we can tell the issue, at least we are able to simulate the issue and we can answer the questions in the interview. See, until unless we are not going into the real time job, we will never know. Most of the interviewers will not understand. Like they will say, you don't have real time experience. They are not accepting us, because
Yeah,
everyone,
uh,
one person, Prakash, I think some just now he suggested one book. Some people will understand the books and they can digest, but my everyone's capability, I don't have that much capable. Like if you can tell me, oh, these are the issues we face, yes,
mhm,
definitely we'll go through the
mhm.
Google and we will find out the issue scenario, how to create, and I can practice. That is my problem. See,
Okay, okay.
everyone. See, even my daughter, she read a book and she will remember like years long. But I cannot I cannot. If I read a book, I will understand the architecture. But in the books, they won't give the real time issues. You are working in a real time company. You will face so many issues. Just you tell the issue. That's all. We will crack down the issue. We will fix the issue. We will create the scenario also.
Yeah, one another thing is you will come to know all these
That's what
things
we
when
go
you
for
do the
trainings, right?
practice.
That's
Yeah.
what we go for trainings. Definitely, we will share some real-time problems. Those problems we will create it. You don't waste time to create the problem in our environment. We will create, we will simulate, we will fix the issue. Those issues we can easily represent in our interviews. That is my problem.
Prasad, one thing, what I used to do. Let me share my experience. Because if you watch the community help of Cloudera, right? So there, every day there will be one new scenario will be there. So generally, what I do that I use those scenario to build up my experience based on talking about different kind of scenario. So if interviewer talks about some other scenario, most of the scenarios are represented into Cloudera community blogs.
Yeah, well done, RK. Yeah, that's a very good thing to do.
And
Absolutely brilliant. Nice one.
yeah, and the beauty of that thing is that those scenarios are not only question but the solution as well. So we don't need to go anywhere other than those blogs. That's what I do.
Okay, I will follow. Definitely, I will follow. If you have a proper link, you just share in the this thing chart. I will save and I will go through that one also. Definitely, I will go through that one.
Just search Cloudera blog, community blog. But I will do that thing. Okay, thank you.
Okay, so this was missing that driver, and so when I install this driver here using this command, so MySQL connector jar. So basically, this package I install, and the jar file is something like something looks like this one. You can just use the find command and get that. See, so MySQL connector jar. So this jar file is needed for connecting this MySQL database using any Java application. So that was missing, and that is the reason we were not able to start this Metastore service. So after adding that, so this service is up and running. So okay, so that's it about the Hive high availability. So we can add multiple Hive server to also Hive Metastore server. So Metastore server will take care of this Metastore service, and that connect with the metadata database that we use in backend.
Shigesh, I
Yeah.
face one problem about two problem for the Metastore connectivity. So there, what I was suggested, some kind of setting of the class path. And second was that to tune the parameters of for the Hive. So can you please explain a little bit?
Class path issue, that the one we have just seen, or
Yeah, same. But where do we suggest? Where do we, lit bash profile or something like that, or INI or XML, right? We need to set some parameters, some path. But can you please throw some more lights on that thing? If
yes, see the class path, definitely. So yeah, it has to by default. Okay, so it contain list of location class underscore path. So if you want to set that, so there are some profile file. Okay, etc profile. So etc profile, if you set something here, so it will be globally applied to all the users or entire system. Okay, so you can just add like so if you have something like export this path, class path, or whatever the path, and you can add the new path and add your jar files over there. So, but I just used the default one like slash user Java, or this path. This comes as part of the default location. So better option is you can add it in the etc profile file itself. So that will be applicable to the entire system. Okay, and the second thing is this one you're talking about, right? The performance tuning or high performance tuning, right? Hello?
yes,
Okay,
yes,
okay.
yes.
The performance tuning, I will just, because again that has a lot of parameters we need to do. Basically, we have option to set certain values like memory, mainly the memory and the other parameters like so MapReduce slot, MapReduce memory. So those things also we can set. Again, maybe I'll just try to cover that uh, next week or next class, because again I also have to revisit that. So I've done it very long back. So it's again a very
That's fine,
vast
Shigesh. We can cover
topic.
next week.
Yeah,
We can cover
just
next week.
remind me that. Okay, I'll just make a note of that and will add.
Yeah.
So
I made a list of the reminder. Okay, thank you.
okay, yeah. So so some parameters are there. So definitely that will improve the performance of our job. So that also we can do that. Yeah. So I think there is itself. I mean, the Hortonworks and all. If you go there, there is a separate topic itself for high performance tuning. So I think very big book itself available. So just I think it's in, yeah, Hortonworks has its own separate documentation. So I tried this Hortonworks thing some time back. It's around 41 page. So a lot of parameters and options are there. So that will improve the performance. I'll just go through this a couple of documentation and will show you. So because again I also did a very long back. Okay, so just let's take just a 5 minutes break and we'll continue.
I think is it hang? Anybody can listen?
Yeah, I can hear you.
So is it?
It's not hang. No. Satish has gone for a break.
Oh, okay.
So Arcade, do you work as a Hadoop admin or what do you do? Hello, you still there?
Hello.
Hi.
Yeah. So let's quickly move to Hive. This Yarn. So Yarn is the main one of the main component in Hadoop ecosystem. So we have HDFS and Yarn, which is the backend of most of the other ecosystem components. So if you look into the Hive, so in backend it's using HDFS, and for running the job it's using Yarn. So if you look into the Yarn, so you can see this many services: the resource manager, node manager, and job history server. So resource manager is the master component. Okay, so which will be running on the master. So we have a resource manager, and we have node manager, and so we have got multiple node managers, and we have one or more resource manager. So resource manager is the master component, and these are the workers. And application history service. Okay, so application history, that it will take care of this job history or job history server. So that will take care of this job history. Okay, so you can whatever the completed job details, everything is tracked by this job history server. And if you look into the resource manager in backend, it's using main task. It's like a scheduling and application manager. So, okay, so it has got a scheduler and application manager. So scheduler will take care of job scheduling, and application manager will be taking care of the application. So here we call that job as application. Okay, so don't confuse this terminology with other. So the job may be any job that we submitted here. Say for example, the Pi job that we submitted here, or any other job that we submitted. So this is called application. Okay, so say for example, so we normally use Hadoop jar. This is one up. When we submit this one, so this will run a MapReduce job. Okay, so how many mappers, how many reducers, and all, it's determined by the configuration or sometimes the runtime parameters that we provide, and it will as allocated first. It when we submit the job, then it will request that to resource manager. First, the request from the client, the request go to the resource manager. So the resource manager have the scheduler in place and application manager. So based on the scheduling policies and the requirement from this job. Okay, so this is the job like we submitted here. So this is one job, and this job require this much mappers and this much reducers. So that's defined by the runtime parameter option. So we just okay, requested. So I need this much mappers and this much samples per map. So based on that, the scheduler has its own scheduling policy. So I'll explain the scheduler part in detail. Okay, so we have got different scheduling policies available. We can change that. Then, so based on the availability, so definitely this node manager and resource manager heartbeat mechanism is there. Then it will send the information like available CPU and memory. So every job require certain set of CPU and memory to run. Okay, so when the request reach here, then based on the scheduling policies and requirement, so resource manager will connect to then one of the node manager, and so there will be an application master for that job. Okay, so application master is just a JVM process. So a JVM process is something like it require any one sort of some portion of memory and the CPU. So this JVM process is called application master. So in Yarn, any job is get submitted. So first a JVM process will be created that is called application master. So the role of application master here. So don't confuse with application manager component here. So this is separated JVM process. So this will be created for a specific job. And once the job is completed, so it release its memory and it will finish. So I mean the application master itself will release and that's it. The life of application master is till the job finish. And based on that number of CPU or resources it need, then so it will try to create another JVM process. So sometimes if the job is very small and doesn't require another process to run map or reduce tasks, then you can see like Uber mode. So Uber mode is something like the job will run as just an application master. Then application master itself will do that map or reduce task. When you submit the job and if you see the log file and you can see this job, sorry, with the Uber mode is false, you can see. So running Uber mode false. That means, so Uber mode false means, so this application master, okay, so this is a JVM process and based on its need, it will so 1 second. Okay, so based on its requirement, maybe here I need 100 mappers. So then it need more JVM process to launch. Then based on the availability, then this application master will negotiate with this resource manager. Okay, so I need few more workers to do the job. Then based on the scheduling or availability, so it will ask the remaining node managers to spawn some more JVM process. So maybe here and all. So it's all depending on the number of, I mean the container. So we call this as a containers. So container is nothing but a JVM process. So JVM process which require some sort of CPU and memory. Okay. And this container is responsible for doing map or reduce job. And the application master will coordinate all these thing. Okay. So all this thing is controlled by application master. So then once the job is finished, then the application master will pass that information to resource manager and finally that result will be maybe the result it's writing to its own HDFS directory or maybe the result will be printed on the screen or something like that based on that. So here if you look into this one, so we have got mainly two components, the resource manager that is a master component and node manager that is a worker component. So resource manager has the role like scheduler and application management. Scheduler means it will schedule the job based on the availability and requirement from the user, or maybe it can be an application or process or user, whoever submit the yarn job. And here we have got the worker component that is called node manager. So node manager, so actually this JVM process so is created by this node manager. Also the node manager will send the heartbeat to resource manager so that resource manager will be knowing what are the resources available and all. And for every job there will be an application master. So application master is nothing but a JVM process that will control a specific job. Once the job is completed, all these containers will be released, and its memory and CPUs will be released back, and this application master also will uh, release its resources. Okay, so let me reiterate again. So in Yarn, we have got mainly two components. One is resource manager, second is node manager. So resource manager is a master component. Again, it's a single point failure, but however, we can add multiple resource manager to enable high availability. And we have got node managers, so which is running on the worker host. So similar to data node in HDFS, so in Yarn, node manager is the worker component, and resource manager is a master component. So when somebody requests or someone submit the job, then the resource manager will accept that. So accept means when you submit any job, so first you can see it's in accepted state. So that means the job is submitted to the resource manager. Then it check the scheduler and other parameters like so what how much he requested or what is the availability. Based on that, the resource manager will send that request to one of the node manager to create a JVM process called application master. Then application master will then control this job. Okay, so application master will check how much resources it need, and it negotiate with the resource manager. And say for example we need a few more resources, and it asks this application resource manager to create another JVM process. Then the new JVM process will be created for this, and that is called container, and each container is responsible for running map or reduce job. And once the job is done again, so maybe we have for the same job, so we have a multiple okay, say for example, so this is performing slow, then this application master will request for another container to run the same task. Maybe if this is slow or some of the job container fails, in that case it will create another container and do the same job. Finally we will get the result here. Okay, and this is how many containers we can create, or what is this, how many jobs we can run. This is all based on number of CPU and memory available in our system. Okay, so CPU and memory availability is a factor that control how many containers we can launch. So how many containers we can launch means how many map or reduce tasks that we can run simultaneously. So that is controlled by CPU and memory. Then if you any questions, you can just
How can we see the history of the application ID? How much CPU it used, something like that?
okay, I'll show that. We have option like resource manager.
Yes, can you explain little more about application manager here?
Application manager is just a process, or we can say under in resource manager, this is the resource manager has got two roles. Okay, so application manager part mainly, so this part only control the job, and scheduler is mainly control the scheduling. So we cannot see it's running as a separate process. We can say it's like two roles of this process, resource manager. So maybe you can say like, see if it's approaching to resource manager, that means the application manager portion. See in resource manager has mainly two roles. Okay, one is scheduling. Scheduling means like checking the availability, and based on that it will okay tell, okay, so this host is available, you can do that. Second is controlling the job, like creating a new application master and monitoring the other. All these things are done through this application manager. Okay, So, but if you just see here, it's just a role, one of the role that resource manager is doing. So you cannot see a separate process with that name.
We will verify that user related authentications when user is submitting a job, and which process will take care of this
That is a
authentication.
resource manager will take care of that. Okay. So resource manager will take care. Okay, so this is the person, and whether he is okay. So whether he is okay to use this queue, he is a right person to do that. Is there any restrictions he has? So it's all done by the resource manager. So mainly we can say the resource manager has got two roles: scheduling and application management. So these are the two roles. Okay.
Okay, okay,
So resource manager is the main core part.
okay.
Then it
It's
it
not a process
con
like application
no,
manager
no,
is not.
no, no, no. This is just roles, I can say. It's
Okay,
not a process. So process is resource manager. Okay. So and node managers. So even okay. So don't confuse. We can say process means sometimes people get confused. So it's we can say daemon. So in Unix terminology we call daemon, and so node manager also daemon, and this application master. Okay, so this is just a this is we can say process or container. So that is a JVM process, and people call the container. Okay, and this is for a particular job. So resource manager will run as a simple daemon. So if you see here, you can see this is the resource manager. So only one process is running. And also if you go to the master one, if you just see ps-ef and then -i resource manager. See, so you can see that process is running. Okay. So this is just a JVM process, and this much memory it's using. So okay. So this is just a JVM process. Resource manager is also a JVM process. Okay. So in Hadoop, so everything, maybe data node, everything run as a Java process. Okay. And the resource manager is a master component. So all the things like whenever the user submit, whether and he requests for okay this much CPU or this much slots I need to have this much mappers and reducer. All the things is controlled by resource manager. So he will check okay, so this person's quota is available, so he is okay to use this resource. All these things are controlled by resource manager. And then a resource manager has main role is like, so we can say, so this is divided into two parts logically. So one is scheduling, second is application management. So application management is a role like, so submitting the application, then getting that results back, then allocating that resources. Scheduler is something like just uh, assigning whatever the resources to this job, and keep monitoring the node manager and get that information. And also it will check okay, so this person is okay to use this much resources, okay, what queue he belongs to, all these things, or which what is the default queue we can allocate to him. All these things comes under scheduling part. So all together, this resource manager itself is a single daemon that will do this job. And we have multiple node manager. So node manager will spawn another process called this JVM process called container. So container requires certain amount of memory and CPU. So it can have multiple containers created. So the number of containers it can create depending on the CPU or memory available on the worker host, because we cannot launch multiple containers more than its memory. Say for example, it's having 16 gig, so maybe some portion of this memory we will choose for operating system and other. Say for example, post to that we have a 6 gig available. then we should be able to create, or we can have maximum 6 containers only. So that means, and also the number of cores available also we need to consider. So we will see that in the yarn tuning part. So this one will control how many containers we can. So container is nothing but a JVM process where we run our map or reduce job. Okay. So that will be run on this container. So the number of container, again, it's a configurable parameter. By using certain parameters, we can control that how many number of parameters maximum we can, and what is the memory and the CPU per container, all those things. So first step is when he or she submit the job, then resource manager is a master part. So it will check all the things, and based on the availability, first it will launch an container. So that is called application master. So application master JVM will be specific to a job. So when the job complete, this application master will be destroyed. That means all the memory and the CPU will be released. And the application master will think and okay, so based on the requirement, it will request for another JVM containers. So sometimes if the job is so small and it doesn't require much containers, then it will run the job in application manager itself. So that job is called Uber mode. Okay, so most of the case you can see the Uber mode is false when you see that log files. Okay, so when you complete the job, so you can see that, so this job is running in Uber mode, it's saying is false. So that means, so this application has spawned multiple containers, and the job is running on multiple containers. And number of containers and all, we can, container is nothing but a JVM process. Okay, don't confuse. There are some terminologies like container, application master. This is the most confusing part. Okay, so how yarn work is, in simple words, we have a resource manager, which is a master. We have node manager, which is a worker. So the role of resource manager is scheduling and application management. Scheduling is nothing but the technically the term refers. Application management also the same thing. The application here means it's nothing but the job that we submit. Okay. So scheduler and job management. So job management will manage the job. So these are the role of a resource manager at a very high level. And a node manager is responsible for spawning JVM process called containers. I mean, so it can be used for mapper or reducer, or it will create another container called application master. Okay, application master also run on the node manager, so don't confuse that. So here also we can have another application master for another job. Okay, so one job will have only one application master. So in real-time cluster, there may be n number of jobs running simultaneously. Each will have its own application master. So how the job works is, when he or she submit a job, then resource manager will have all the information. So first we will accept. So you can see the job is in accepted state. Then if the resource is not available, okay, scheduler say no resource available, it will be there in accepted state for some time. Then based on the availability, how it know the availability again? The question is, so there is a heartbeat mechanism between the resource manager and node manager. So the heartbeat along with it send the details about available resources and all. So when the job submit, the resource manager
what is the
will
interval for heartbeat here?
I think it's a 3 second or something. So every 3 seconds it will send that information back to resource manager. So 3 second, it's a time limit. Okay. See, this application master is specific to the job. The role of application master is to negotiate with the resource manager and saying, okay, so I need this much. This is just like see, in simple word, say for example, if you have a project, we are hiring a contractor to execute that. I mean, a contractor manager. See, I have a project. I'm just hiring a contractor manager, and then sometimes he will do the job alone. So that is Uber mode. Okay. So he do the job alone, and then once the job is done, then we are happy. Then we will say, okay, your contract is over, you can go. So that is a Uber mode. Sometimes this contractor says, say, I need this much resources for executing. So say for example, this is the uh, company and this is the contractor. So application master, we can compare it with a contractor manager. And he will say, okay, I will do it for you. Then once this is done, that is a Uber mode. Sometimes this person say, I need 5 resources to execute. Okay, so this will say, okay, you can make use. And he will create another containers like this. And so he will execute. Once this is done, so not only this manager and whatever the additional resources he had also will be terminated. Then the project is over. So you can compare this with that scenario. So any questions here?
Sujesh, so application master, it will be created on, take example, resource manager says, okay, a new job I have accepted. So there's a one application master created on, say, take example of node worker or data node 1.
Mm.
And then multiple containers being created to execute the same job. So take example,
Yes.
one has created on node 1, node 2, and node 3. However,
Mm.
application master for that job is only one. Is that correct?
Yes, one job will have only one application master.
Yeah. So take example, if that job application master is running on node 1 or worker 1, and that node goes down somehow. So then what in that situation, I assume that since it won't be able to communicate with the resource manager would spawn a new application master on some other node. Is that right thinking?
Correct.
Okay.
And if application master is okay and working, and some other container goes down, then again, so application master initiate for launching separate container for that job, because the Hadoop is defined with I mean especially on the worker side, so availability in place. So if one goes down, not only the if it down, so if the performance is very slow with, okay, say for example, we have the application master, and application master launch a few containers like this. So maybe it's running some app job. So for example, this job is running deadly slow. So all other jobs has completed and waiting for this. Then what it will do? So it will launch this one container for the same job. Okay, and this type of execution is called speculative execution. Okay, so that is the one. And so it makes sure, like, so our job is completing in time. And another thing, okay, see, the another we all think our job is executing in a parallel way. Okay, but that may not happen in real time scenario. Say for example, I requested a job with 100 mapper, or some example, a number of reducers. See here in our case, pi example, so it's making use of one reducer alone. So we will just submit the job and see how it works. Okay, so 100 mapper and 10 samples. Okay, so this is something like specific to this example code. And so here they are expecting the mappers that they have something in the configuration inside the code itself. So we just use a Hadoop jar, then the remaining things are up to the developer. Okay, so this is all developers logic, and whatever the parameters we are passing is on based on this one. Just enter. So now if I just go to the resource manager, just I can go to the web UI, resource manager UI, I can see one job is in accepted state. So accepted state means one it's just launch the application master. So you can see container running is 1. So allocated vcore is 1 and memory is 1. So this is allocated for the application master. Now if you refresh for some time, see this job 002 is changed to running state. Now if you see here, see this is the job ID, application ID. So 000970002. 97002. This is the application ID and who has submitted, what is the code name, and what is the type of application, what is the queue, and when it started and what is the status, everything is there. Now you can see the container is changed to 3. So initially when it's in accepted state, only 1 container. Now 3 containers are there. Okay, so 3 containers means 1 application master and 1 second. So this will not. See, I just use this link, and the reason is it was just initially using that private IP. That is the reason we were not able to see that. Just replace that with the public IP or public host name. So when you just refresh, you can see the progress here, and so this is running, and total map it requires 100 and 54 has completed. And how many reducers it need is 1, and how many reducers completed is 0. Now if you just hit there, and you can see how many are pending and how many are running. See, at a time, okay, so come back here, you can see 3 containers only running in our specific case. 3 containers. Okay, so maybe 1 container from each. Okay, so 1 is dedicated for application master. So we have got only 3 worker in our current scenario, and so this is for a map job, and this is also another map job is running. So even though we requested for 100, so at a time only 2 are running. Okay, so if you have 100 host available or 101 host available, so 1 we can use for application master and the remaining 100 for running or your worker, then only your job run in parallel way. Otherwise, how it will run? So initially 98 will be waiting and 2 will run. Okay, so 98 will waiting state and 2 will run. Then okay, so this is completed is now 2 complete, and 96 will be waiting, 2 other will be running. Then 94 will be running, 2 and 4. So this is completed. So this is in progress and this is waiting. So even though we are expecting our things in parallel, so actually it's not running in parallel because of our limited hardware. See, if I have 100 plus 1 or 100 plus worker host available, so all this will run in parallel and I will be getting my result in a quicker way. Okay, but in real scenario, so we won't get 100% parallelism. So only, even though we are getting some portion of parallel execution, plus it's running in a sequential mode only. At least if we expand or increase the hardware, then only thing is, so it should be able to, instead of 2, it may be able to 5 at a time. So it will increase the speed. So that is what we can see here. Just refresh, and we can, I think it might have completed. Yes, if this is this is now completed. Okay, and here where there is one thing called queue. And the queue I will show you in detail. So how the queuing works. So if multiple people submit, what will happen? What are the different scheduling policies available? All these things we will see. So any questions? How many containers required for a job? That is one question. So number of containers based on the number of mapper and reducer we need. See here I submitted. Okay, it's all depends on the job. Also, it's all depends on how we submit the job. Say for example, here I just submitted 10 like this. Okay, so I just need a 10 mapper and one reducer. So if I just refresh this, it's initially it's in accepted state. So you can see one container is running. So even though one container is running, it's not running state. The reason is that container is used for application master. So application master will take care of this job. It's just a manager kind of thing. So he won't do the job. So if he is using running the job, so we will call it as a Uber mode. But most of the case, so he will request for other container. So now one more container is launched. So two are running. I think this is finished because it's going fast and only we requested uh, 3 or I mean we requested for 10 mapper. So sometimes we request for more mappers. It's all based on the program that we run that require how many mappers or how many reducers. So based on that, so it need a container. See if I request for 100 mapper or 100 mapper job, so it require 100 container. But at a time we cannot launch the 100 containers. So we will launch the containers in a sequential way, not as the resource manager and node managers. And it based on the completion of the job, then it will do that. So you can see a lot of containers or a lot of mapper or reducer job in the waiting list while others are running. So basically a one mapper or reducer job require one container. So if you have multiple containers, multiple mapper or reducer job, definitely we need multiple containers. So these containers will be across the worker host. So any other questions? So if everyone is good, then we will wind up for now and we'll continue next week.
Thank you, Shiki.
Right.
Yeah.
Thank you.
Yeah, bye.
Kalak pa dyan, tama ito, focus na.